Hello children, today we are continuing with chapter 5 heat and today is part 2. Today we are discussing about thermal expansion. According to the definition, expansion produced in matter due to absorption of heat energy. So, if matter can be in 3 states: solid, liquid or gas. So, when solid, liquid or gas expands due to absorption of heat, this expansion of solid, liquid or gas is called thermal expansion. Now, exactly how does the expansion takes place? Now, as you know, all matter is made up of molecules, and at the molecule level you need to understand exactly what is happening. So, as you know, in a solid state the molecules are arranged tightly, very close to each other. So, when you supply heat to the solid, these molecules starts getting heat energy, and this heat energy gets translated to kinetic energy. Kinetic energy means the energy due to motion, and these molecules they start vibrating or moving. So, as they move, this one molecule starts occupying more space, and so does the next molecule. So does the next molecule. So as you can see, a molecule that would have occupied just so much space if it was at a certain temperature, when you hit the solid, you can find that now the same 3 molecules occupy a much larger space. So because of the intermolecular distance, that means the distance between the molecules increase because of the vibration or the motion of the molecules due to heat. There is an expansion of the solid or the liquid or the gas. Now, let me tell you the explanation part. Explanation of thermal expansion. So, when a substance is heated, molecules start moving vigorously or faster. As you can see, molecules are not moving so much. Here, when you supply heat, the molecule starts moving and it creates a gap between the molecules, which causes the entire thing to expand. The distance between the molecules increases and the substance expands. As you can see that the intermolecular distance, that means the distance between the 2 molecules has increased as compared to the intermolecular distance here. Here the distance is small, here the distance is larger. So, overall there is an expansion. Now, let us try to understand the amount of expansion in solid, liquid and gases. As you know, the molecules in a solid are very tightly packed. So, and the reason why it is tightly packed is because the molecules are very close and there is the attraction between the molecules are large. So, if a molecule does get heat and it expands, it does not expand so much because the forces of attraction are still at play, and the solid expands, but not so much, although there is an appreciable expansion. In the case of liquids, the distance between the molecules are much larger and the molecules are free to move about in the liquid. So, in this case, when heat is supplied, the molecules are able to move much further away from each other. So, in the case of liquids, the expansion is much more than that of solid. And the last state of matter, the gas. In case of gas, there is hardly any attraction between the molecules, and the molecules are free to move about wherever they like. So, because the distance between the molecules are very large, the force of attraction between the molecules is not so much. Okay. So, when you supply heat to this, the gas is able to expand much more as compared to solid or liquid. So, in this case, solid expands a little, liquids expand more than solid, and gases they expand a lot. Next, let us discuss about the application of thermal expansion in solids. As we have understood that solids, liquids and gases expand on heating. So, these are some of the applications of thermal expansion of solids. The first one, let us discuss about that small gaps are left between successive So, those of you who have the experience of traveling by train, you must have seen the train moves on a track, and between the tracks, between one length of the track and the next length of the track, which is actually bound together by plates and they are riveted together, there is a gap in between the railway tracks. So, this is, let us say, one railway track and this is the other rail track. Where one railway track ends and the other railway track betweens, there is always a gap that is left in between. The reason is because this railway track is made of iron, and this iron track is kept out in the open. So, when the sun shines and it heats up the track absorbs the heat energy and it expands. So, when it expands, this gap gets filled up because this track expands this way and this track expands the other way, and the gap between the two tracks becomes very close. So, supposing if the railway track was kept in such a way that there was no gap in between, so when during the day when the sun shines on the railway track, at the time if there is no gap, these two railway tracks would have pushed against each other and they would have bent. So, to prevent the railway track from bending and causing a problem, or it can even cause an accident, so the gap is left in railway track to allow for the expansion due to heating. So, this is one of the applications of thermal expansion of solids, and by this knowledge we know that we must leave a gap between the railway tracks. Number 2 is all right. So, this is iron girder bridges, that means bridges which is made up entirely of iron, okay, are fixed only from one end and the other rests on rollers. Supposing if you have two posts like this, okay, across which a bridge is kept. So, let us say this is the bridge. So, one side the bridge is fixed. So, let us say this is the end where the bridge is fixed to the post, but the other end is always kept on a roller. The reason is because this iron girder bridge, when it absorbs heat during the day, it expands, and when it expands, at the fixed end, since the bridge cannot expand, the bridge expands on the other end, and because it is resting on rollers, the bridge rolls over the rollers and it expands easily. But supposing if this was fixed, then what would happen was when the bridge expanded, it would have pushed this pillar left and right as it expanded and contract, and this pillar would have broken. So, to prevent that from happening, the bridge is always fixed at one end and the other end it is kept on rollers. So, when the bridge expands, the bridge can simply roll over the rollers, expand, and when in the evening when it cools down, it contracts and rolls back to its original position. So, this is an application of thermal expansion of solids in which bridges are kept on rollers on one end to allow for expansion due to heating. Let us talk about let us say telephone poles, telephone wires are kept sagging when installed in summer to prevent them from snapping in winter. So, let us say this is a telephone pole across which wires are strung. So, if you are installing this telephone pole during the summer season, at that time you do not install the wire in such a way that it is tight across the two poles. What you do is you allow it some slack and you allow the wire to hang a little loose from one end to the other end if you are installing in the summer, because what happens is during the winter months, this wire, because it cools down, it contracts, and during the winter you will find that the same wire which was sagging during the summer season would have become tight over between the poles. So, this sagging of the wire between the poles allows for enough space for contraction during the winter. Now, supposing if during the summer this wire was stretched across, what do you think happened during the winter? During the winter, the wire would have contracted and become more tighter, and because of the tension, the wire can possibly snap. So, whenever you are installing during the summer season, you always install in such a way that it sags across the poles, so that during the winter season, when it cools down and contracts, the same wire becomes tight across the poles, okay, and there is no tension between the wires because you have given it some slack during the summer. So, this is an example of application of expansion of solids when installing telephone pole wires. The last one is bimetallic strip, BIMETA. Alright, so this is it. The bimetallic strip are used as thermostat in electrical heating devices to control temperature. A bimetallic strip means bi means two, metallic means metal, so two metal strips. So, generally we take a strip of iron and a strip of copper, we drill holes through them and through which we pass rivets, and those rivets are tightened so that it holds the two metal strips together. So, let me shade the iron part of it to indicate this is iron. Now, the property of this bimetallic strip is that when you take a bimetallic strip which is made of copper and iron, let us say iron is at the top, let us say I for iron and C for copper. So, when you heat this, you will find that it bends, and it bends in such a way, let us say this is the state in which it is heated and it is bent in such a way that iron is on the inner side of the curvature and the copper is on the outside part of the curvature. The reason is because metals expands differently due on heating. That means, in this case copper expands much more than iron, and therefore, because copper is expanding much more, it expands and it causes the whole metal to curve. So, you can see that it is copper is curved and it is on the outside and expanded more, and iron expands less and it is on the inside of the curve. Now, this property can be used to make a thermostat. A thermostat is a device which is used for controlling temperature. So, let us say you have a bimetallic strip made of iron and then copper, and one side is an electrical point through which electric current flows. Let us say C for current, for example, current is flowing through, and there is a contact point here at the other end. So, through which electric current flows out. Now, let us say this device is placed in a electric iron. You must have used an electric iron to iron your clothes, and as you know that you need a specific temperature to iron your clothes, and if the temperature of the iron becomes too hot, then it might burn your clothes. So, the temperature of the iron must be controlled so that you are able to iron your shirt without, or iron your clothes without causing any damage. So, when this, let us say this is the heating element, and this heating element, it heats the electric iron, and this also heats the bimetallic strip at the same time. So, when the temperature rises, this bimetallic strip gets heated and it causes the bimetallic strip to curve like this, and it causes the connection to break. So, the heating element stops heating and there is no further heat is supplied to electric iron. But what happens after some time is that because the heating element is not supplying any heat, the bimetallic strip starts cooling down, and as it cools down, it becomes straight again, and the connection is established and the current starts flowing again, and that current starts supplying heat to the heating element, and it starts heating the electric iron as well as the bimetallic strip again. So, in this way a bimetallic strip switches off the current to the heating element when the temperature rises beyond a certain point, and then again it connects back and again heats the element. So, therefore, because it is controlling the heating element, so therefore, it is controlling the temperature of the electric iron, so that you can safely iron your clothes. This is all for today. Thank you, everyone.